Okay, today we are looking at the law of cosines. So in the previous section, we talked about how we can solve triangles that aren't right triangles using the law of sines. And we said that we use law of sines when we have an angle-angle-side, an angle-side-angle, or a side-side angle, which was the ambiguous case. We use law of cosines for the other two. So law of cosines is only when you've got at least two sides. So side, 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 or side, angle, side. I've written out your laws of cosines here. And really these are all just variations of the same formula. You just have to swap out the angle for whichever side is by itself. So in this case, because a squared is on the side by itself, it's the cosine of angle A that goes in the formula. Here, b squared is by itself, so it's cosine of b, so on and so forth. So obviously, we are either solving for angle A, angle B, or angle C if it's a side, 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 or if we have an angle, then that locks us into which formula we have to use. So if you choose to use law of sines after the law of cosines to solve the rest of the triangle, you have to make sure you watch out for the ambiguous case and make sure that you have the correct solution. If you continue to use law of cosines rather than switching to law of sines, then that would avoid that problem. So if you're worried that you're not going to recognize when there needs to be a check for the ambiguous case, then just stick with law of cosines once you've started with it. But you are allowed to switch over to law of sines as long as you can remember to check for that. Okay, so just like we did in 9-2, the first thing I'm going to do with my given information is draw a picture. So this is obviously a side, 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 no degree measurements here, so these are all side lengths. So draw myself a triangle, and the longest side is side C, so 73 should be across from angle C. Then side B is 51. And side A is 42. So here is my triangle ABC with all of my sides matched up. So when I solve for an angle, so when it's a side, 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 I typically think it's easier to start with the largest side and find the largest angle first. You can do it either way, but I think that leads to less variation, which is a little less thinking. So we're going to use this formula right here, the one where c squared is by itself, because c is the biggest side, so therefore angle C should be the largest angle. So 73 squared equals 42 squared plus 51 squared minus 2 times 42 times 51 times the cosine of angle C. Now, hopefully we have not forgotten order of operations, because if you try to rush through, you might miss it, which obviously we need to be careful to make sure that doesn't happen. So when I square the 73, I get this. Here, 42 squared plus 51 squared. And so that gives me 4365. Then this is multiplication. So 2 times 42 times 51 gives me 4284. Times the cosine of angle C. So here is what I see some students do. Do not let it be you. You cannot subtract these guys. This has multiplication here. You can't just do subtraction before multiplication. PEMDAS says no. So I have to solve for C, which means that what I really need to do is to subtract on both sides. So 5329 minus 4365 gives me 964, and that equals negative 4284 cosine C. So divide. And that's going to give me cosine of C alone. So I don't have to reduce this or get a decimal or anything. I can put that into my calculator as is, because I know I'm going to need to use inverse cosine. So inverse cosine of 964 over 4284 is going to give me angle C. So type that in. And that gives me 103, and I'll put 0.0 because obviously it's a rounded value. So 103 degrees. So here is where I can, if I want, switch over to law of sines. Again, in a non-right triangle, there's no way to avoid using what I've calculated. We don't do that in right triangles, but we have to in non-right triangles. So if I switch over to law of sines here, sine of 103 over side C equals sine of A over A or sine of B over B. I usually go biggest to smallest, so I'm going to do sine of B over 51. And then now this looks exactly like what we did in section 9.2. We are simply going to use our law of sines here to get angle B alone. So 51 times the sine of 103, and then divide that result by 73. So that gives me 0.6807, and that's the sine of B. So inverse sine, and second answer. So 42.9 degrees. Now, here is where I said if you're going to switch over to law of sines, you need to make sure that you remember to check because of the ambiguous case that sometimes it could be the other triangle rather than this triangle. But if I do 180 minus 42.4, that together with angle C is too big. So I know in this case that this has to be the right angle B. So then my final step is to find angle A by doing 180 minus the sum of B and C. And so I've got angle A. We already had B is 42.9. And angle A we then find to be 34.1. Also, just as another common sense check for yourself, make sure when you're finished solving the triangle, again, the triangle inequality theorem from geometry tells us that the longest side has to be across from the biggest angle. The smallest side has to be across from the smallest angle. So just make sure that your values make sense in that context as well. That can kind of help you to catch a mistake. All right, example 1B, I've got angle A set at 61 degrees, and then I've got sides B and C. So a 61 degree angle here for angle A. I don't know side A, but I do know side B and side C, so we'll make this C at 6. We'll make this B at 4. So here is what my triangle looks like. This is a side angle side, where again, this one was a side. So on side angle side, I'm locked into which formula I'm using because it's based on the angle that I'm given. So in this case, I have angle A, so I'm going to use this formula. So A squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of angle A. Now, side angle sides are the ones that we like because all of our numbers are on the right side, which means I can actually press this entire thing into my calculator all at once. So it saves me some time for sure. So 4 squared plus 6 squared, and then just type exactly as you see it. You don't have to simplify anything. And that tells me that a squared is approximately 28.729. So to solve for side A, I would square root both sides. And of course, that means I'm going to use the second answer button on my calculator. So square root of that answer, which then gives me 5.36 when I round it to the nearest hundredth. Again, you can switch over to law of sines as long as you remember to check for ambiguous case. So sine of 61 over A equals sine of B or C. Actually, probably find C first because it's bigger, over 6, and cross multiply. So 6 times the sine of 61 degrees divided by 5.36 is going to equal the sine of C. So 6 times the sine of 61 divided by 5.36. So I'm going to be doing inverse sine of 0.979 approximately to equal. So inverse sine of that value, and it gives me 78.3 degrees. So C, 78.3 degrees. So I need to check always to make sure there can't be an ambiguous case. So 180 minus that angle would be 101. So just making sure when I get my other triangle, this would be, let's see, 101.7 degrees is the other option. And so I have to check when I find my sine of B just to make sure that that gives me the correct answer. So set up sine of A over A equals sine of B over B. So 4 times sine of 61 degrees divided by 5.36. And 4 sine 61 divided by, and so this value I'm going to do inverse sine of, so inverse sine of 0.6527 to equal angle B. So I get B to be approximately 40.7 on that. And so when I look, if I did 180 minus that value, that would be 140, approximately 139 point something. And that one's definitely going to be too big with the sine of 61. So that means that this one that I'm locked into is going to be the correct one. So I can toss aside the 101.7 in this case. So angle B would be 40.7, and this is the triangle that I would create. All right. Last one. A cluster of trees is in the way of measuring the entire length of a property boundary line. So, using two sides and an angle, the surveyors measured around it to find the total length of the property line. So, basically they went around the woods, essentially, since they couldn't measure straight through it. So, the entire length of the property line is this. So, when I get my final answer, that's what I'm looking for, is this entire length. So obviously the part that I don't know is the part with the lovely trees. And I do have these sides that they measured around it. They know what angle they measured it at as well. So in this case, this is a side angle side triangle, non-right triangle. So I can use the 80 degrees to find the x. So side angle side, x squared is going to equal 16 squared plus 21 squared. Plugging in that 16 and 21 to the formula, along with the cosine of 80 degrees. So just like we talked about in example 1, when it's side angle side, that means I can really just press this whole thing in. So I don't need to simplify because I don't have to worry about isolating the variable. It's already isolated over there on the left. And so I'm just going to type in the whole thing. And when I type that whole thing in, it gives me 580.308 approximately. So x squared is about 580.308. So I would square root that to find the value of x. So square root of that answer gives me 24.09 approximately. And so that's not my final answer. But I do now know that the part through the trees is about 24.09 feet. It does not say what to round to here, so I would probably just keep it to the nearest hundredth. So I do 30 plus 24.09 plus 43, because that's adding all the pieces of the property line together, which gives me 97.09 feet for my final answer. All right. Law of cosines takes a little longer to set up. It's a little more tedious to solve on the sides, but at least you don't end up with two triangles. Remember that if you don't want to check for the two triangles here or here, instead of switching over to law of sines, you could go back to law of cosines if you wanted. So you could set up, okay, now I know, angle. Now I know side A, so I can plug that in, and I could do B and B over here. So that is totally up to you. Just make sure that if you switch to law of sines, you remember to check.